Hi everyone. Today we're going to learn about scientific notation. We're going to learn about why we write numbers in scientific notation, and we're going to learn about how do we accomplish this. So let's explore what happens if we take any given number and multiply by 10 or 100 or 1,000, a 1 followed by a bunch of zeros. If we multiply by 10, we move the decimal place 1 to the right, or we add a 0 if the decimal place is all the way at the right already. So 18 times 10 is 180. We move the decimal place 1 to the right, had to add a 0. 18 times 100 is 1800. So the decimal place is already at the right, and we move it 2 to the right. Now if we have 1.5, we have to move the decimal place to the right of the 5 and then continue moving accordingly. Now if we look at what integer is equivalent to 10 to the 5th, 10 to the 5th is 10 multiplied by itself 5 times. So you wind up with a 1 followed by 5 zeros. You wind up with 100,000. Now 10 to the negative second, we learned how to convert it to a positive exponent in a previous lesson. So it'd be 1 over 10 squared. 10 squared is 100, so it's 1 divided by 100. And we could read this as 1/100th, or 0.01. So negative exponent, the decimal is going to the left, and a positive exponent, the decimal is going to the right. Now this is going to help us when we write numbers in scientific notation. What scientific notation is a representation of a number when the number is really, really large or really, really small. It's a way to eliminate having to write a bunch of zeros. I like to consider it a way that mathematicians are allowed to be lazy. What we need to understand is that this a value is going to always be between 1 and 10. It could be 1 all the way up to 9.999 times, and we need this symbol is always important, x, don't use the multiplication dot, 10 to a power. And this n can be any integer, it can be positive, and it can be negative. So let's see a few examples of how to do this. 2.6 times 10 to the 7th. We have to write it as a decimal equivalent, so we're going to take it out of scientific notation. So this 10 to the 7th says multiply by 10 7 times. So we're going to move the decimal 7 places to the right. So we move it 1 to get to the end, and then we got to move it 6 more times. So you notice here I got 6 zeros. Really big number. Scientific notation is a lot neater of a way to write it. Now, if the exponent's negative, we're going to move the decimal place to the left. So a negative exponent means the number is really small. It does not mean that the number itself is negative. So you're going to see the answer. We move the decimal place 4 to the left, and we have to add 3 zeros. And the answer is 0.0001, or 1/10,000th. So a really small number, but it's still positive. Now, it really comes in handy when we have to write a number as scientific notation. So we have to count how many decimal spots we need to move to get from the end where the decimal is currently hidden all the way back to in between the first non-zero and the number that comes after it. So we have 4.6, and we move the decimal point 6 spaces. Now, since it's a large number, our exponent should be positive. Now this one, really tiny number, our exponent's negative, and we just once again have to count 1, 2, 3, 4, 5 spots in the negative direction. So we have 2.3 times 10 to the negative 5th. And that's how we take and write decimals into scientific notation, or take scientific notation and write it out in standard form.